Dear students, you are welcome in this class. I'm very pleased to be part of this class. And today we are going to have introduction to the soil fertility. What is soil fertility? How it is different from plant nutrition? What is mineral nutrition? How soil fertility is different from soil productivity? And what is the current status of soil fertility? What are other concepts? And then we will also see soil fertility classes. And we'll also see how to identify the soil fertility problems and what are the solutions, how we can maintain soil fertility. All these aspects I will try to cover in this lecture. Let us see how much can be covered. So before I actually start, I would like to know something from you. Just test your knowledge. So what is soil fertility in your view? Any student can come forward and tell me what is soil fertility, how it is different from soil productivity. Anyone can come. There is no question of shame. Even if you are not correct, you are not right, I am there to correct you. But you should make attempt. This is the time to overcome your shyness. Come forward.
Sir, soil fertility is the inherent ability of the soil to enhance plant growth by supplying nutrients.
Very good. So see, very interestingly, she has not said just that soil fertility is the status of nutrients or supplying status of nutrients in soil. But she has also added, very interestingly, to improve the plant, to help the plant. So this is quite interesting remarks by her. Any other definition of soil fertility? Because mostly people say it is the inherent capacity or ability of soil to supply nutrients in balanced and adequate amounts. But she has added another dimension, that is to get the better plant growth. So any other definition of soil fertility?
Hello, sir.
Yes, please.
So the soil fertility can be defined as the ability of a soil to sustain the plant growth and development by providing the essential plant nutrients and like favorable chemical, physical, and biological characters.
Excellent. So actually, soil fertility is not just restricted to the status of nutrients. It includes something else also. So I will show you definition of Soil Science Society of America and soil fertility. Next is your plant nutrition. What is plant nutrition and how we separate soil fertility from plant nutrition? Any idea? Come fast. Time is very limited.
Hello, sir.
Yeah.
Sir, plant nutrition is a broader concept which includes availability of nutrients, their uptake, and their accumulation. And these three processes include the total plant nutrition.
Yeah, just a minute. Hello. बहुत जल्दी बोलो, मैं क्लास में हूँ. So he has very rightly pointed out or suggested definition of plant nutrition. We will discuss it also. The next is mineral nutrition. How plant nutrition is different from mineral nutrition. Because sometimes you see we write plant nutrition and sometimes we say mineral nutrition. Are they same or are they different? All right. Any difference in soil fertility and productivity? Yes, please. Any difference? Anybody knows the difference in soil fertility and productivity?
Soil fertility is the capacity of the soil to supply nutrients for enhancing growth, whereas the soil productivity is the ability of the soil to produce some crop in terms of hectare or in terms of yield. Means we can say that soil productivity equal to soil fertility plus climate plus management.
Excellent. Excellent. So that is how we see difference in what should be the characteristics or ideal characteristics of a soil to be fertile. That what are the things or what are the factors that will tell us that this particular soil is fertile and this particular soil is less fertile or low fertility, having low fertility. Means how we can distinguish between soils of high fertility and low fertility. Just guess.
So by testing the soil nutrient contents like nitrogen, phosphorus, and potassium.
But so it is just by seeing the nutrient status of the soil. But what about pH? What about CEC? What about soil structure? What about biological activities? So it will also include, besides the chemical property like nutrient status, it will include many other components also, like soil depth and toxic things, soil pollution. You can find good status of nutrient in the soil, but if it is polluted by heavy metals, polluted by pesticide, so you cannot call it a fertile soil. So we need to look into other aspects also. We need to see the components of soil fertility. Next is, what are the principles of soil fertility? Anybody knows principles of soil fertility? So there are three principles of soil fertility. One is law of minimum, other is principle of synchrony, and third one is nutrient recycling or cycling. So these are three principles that we are going to discuss. So learning objectives are to discuss the principles and current status of fertility and describe the difference in fertility and productivity. Some terminology, I think most of you know it, just refreshing your memories. Decomposition, conversion of complex organic materials into the simple forms, followed by release of nutrients through mineralization and formation of humus. Means decomposition of organic matter. This is with respect to organic matter. Means that something is made up of certain constituents, certain compounds, certain chemicals would make something. For example, organic matter, it will be made up of proteins, it will be made up of fats and lignin or proteins, carbohydrates, etc. So this is the composition. And then when you disintegrate it, when you degrade it, when you break it into different simpler compounds, that becomes your decomposition. Fertilizer is chemically synthesized products containing one, two, or more plant nutrients. Humification is simply formation of humus or production of humus after decomposition of organic matter. And when organic matter decomposes, there are two major pathways which are happening in organic matter decomposition. One is humification, other is mineralization. They go hand in hand. Next term is immobilization. When organic matter decomposes, particularly when you have higher CN ratio, at that time microbes consume the available nitrogen from the soil, mainly nitrogen, and then there is shortage of nitrogen at that time. So this conversion of available nitrogen into unavailable nitrogen in the form of taken up by microbes is your immobilization. It is also called as microbial immobilization. Mineralization, when you have organic matter and when it breaks down into different pieces. So there are two pathways. One is humification, other is mineralization. So in mineralization, decomposition of organic matter results in production of certain minerals. Or you can say when you have organic matter, if you burn it, it will be oxidized. And carbon and hydrogen and oxygen will be liberated. They will go away. And what left is your ash. And ash contains all the minerals. Ash contains all the minerals. Of course, during burning, some of the nitrogen and some of the sulfur and some of the phosphorus, they also get away, or they are also lost partly. So whatever is left in the ash are your minerals. And that is done by fire. Similarly, it can be done by oxidation involving microbes. So that is your mineralization, part of decomposition where minerals are released. nutrient cycling. Nutrient cycling is just circulation of minerals, through the terrestrial system, through the water system, and so on. Nutrients, you can see it, the circulation of nutrient substances from their occurrence in the physical environment to their incorporation in the bodies of living organisms, and they are returned to the physical environment. When they recycle, when they change their materials, today they are in X, tomorrow they will be in Y. Essential plant nutrients, you know it, soil aggregation is binding of the primary soil particles. Aggregation means making small clots of sand, silt, clay together. Certain natural forces and root exudates and microbial activity help in binding the particles together. This is important. Certain natural forces, or maybe some attraction, chemical attraction, root exudates and microbial activities. Certain fungi release some material that can bind the particle together. Other microbes also release some organic materials that can bind the particle together. And other role is played by humus. Humus is very important in soil aggregation. It helps in binding the clay particles. Soil fauna are certain species from the animal kingdom living in soil, certain protozoa, nematodes, mites, earthworm, etc. Now we come to the main topic, that is soil fertility. So Somani 1989 gave this definition. Soil fertility is the overall ability of the soil to support the vigorous crop growth, as pointed out by you. So here, growth is also important, that it should, in theory, it should support the vigorous crop growth by ensuring adequate plant nutrients and suitable conditions for water uptake. Because without water availability and uptake, the nutrients cannot be taken up. So the soil should be able to supply the nutrients. But it is possible when you have required water. And water uptake conditions are good, and by providing favorable conditions for root growth. Because without root also your nutrients cannot be taken up by plants and development. So this is perhaps a very good definition. Soil fertility is the overall ability of a soil to support the vigorous crop growth by ensuring adequate plant nutrients and suitable conditions for water uptake, and by providing favorable conditions for root growth and development. So this is complete definition of fertility. However, other definitions like soil fertility is basically related to the status of available nutrients and its capacity to supply the nutrients. Status and capacity to supply the nutrients from its reserves and by outside application. So nutrients can come through the reserve and through the outside application. That is soil fertility. So this definition is brief and it can be remembered easily also, though it is not complete. Other is, it comprises of many properties of soil. So here you can see soil fertility has been broken into properties. So it comprises of many properties of soil, all of which influence the dynamics of nutrients. Dynamics of nutrients and their availability to the plant. So you can see in this definition, it is not just a status of nutrients, which is called as fertility. You can see in this case, there are many more things other than the nutrients, which are part of fertility. And that can influence the availability of the nutrient. For example, aeration. Aeration will surely affect the availability of the nutrients. Similarly, water content. Similarly, soil structure. There are many other things which are component of soil fertility we need to discuss. So if you are not able to understand anything what I discussed, you can stop me there, right there, and we can clarify it. So it should be two-way interaction. Now, plant nutrition versus soil fertility. So soil fertility you have just now seen, and plant nutrition is the subject. It starts where the fertility ends. You have seen that in soil fertility, the status of nutrients and supplying capacity of the soil. Supplying capacity of the nutrients of the soil to the plants. So that is soil fertility. And then comes your uptake. Soil fertility can make the nutrients available. Then after that, plant will take up the nutrient. It is part of plant nutrition. Means uptake of nutrient, then translocation of nutrients in the plant system, then further synthesis of the nutrient, and it will be playing number of roles in the plant. So we need to study uptake, translocation, assimilation, and then role of the nutrient in the plant, and then deficiency symptoms or toxicity symptoms. All these subjects are part of plant nutrition. I think they are complementing each other. Soil fertility, first soil fertility, it will supply the nutrients, and then comes your plant nutrition, which will help in taking up the nutrients from the soil, and then translocation, assimilation, and then if they are deficient, what are the symptoms, what are the roles of nutrients. So that makes part of your plant nutrition. So it studies that effect of elements on plant growth and development, determines the forms and condition of availability and uptake, and establishes the range of beneficial and detrimental effects. So this is plant nutrition. In simpler words, how plants take up the nutrients and use them in their metabolism is called as plant nutrition. So you can have variety of definitions, but you can remember very easily that after soil fertility, the subject of plant nutrition starts uptake, translocation, assimilation, and different roles and deficiency symptoms. Next comes the mineral nutrition. So plant nutrition includes how many elements are essential for plant growth? How many elements are essential for plant growth?
17.
How many?
17.
17, yeah. So in 17, carbon, hydrogen, and oxygen. These three important nutrients are considered as framework element that make the major framework of plants, because carbon can be 40 to 45%, oxygen can be 40 to 45%, and hydrogen can be 5 to 8%. So you can see about 95% plant is carbon, hydrogen, oxygen. So, but we do not normally talk about carbon, hydrogen, and oxygen nutrition to the plant, because these elements plants are getting from the nature in the natural form. So human being is not feeding plants hydrogen. Human being is not feeding plants oxygen. And so is the case of carbon. Carbon is coming as CO2, hydrogen from water, and oxygen from water and carbon dioxide. So there is no need for any nutrition. So plant nutrition includes all the 17 essential nutrients, including carbon, hydrogen, oxygen. However, mineral nutrition includes your 17 minus carbon, hydrogen, oxygen, where mineral nutrition is studied. Means nutrients are taken up in ionic form by the plants. Those kind of studies are the subject of mineral nutrition, which exclude carbon, hydrogen, and oxygen. Now, the study, mineral nutrition is the study of absorption of inorganic mineral elements, and their assimilation by plants is your mineral nutrition. Roots absorb mineral nutrients in the form of their salts dissolved in soil water. That is another reason that it is called as mineral nutrition, because nutrients are removed as ions, but they are kind of salt, Earth's crust, and another thing, how these minerals come. Earth's crust or rock, weathering process, you understand. Physical, chemical, biological weathering is there, from which the rock material is converted into soil. And then soil minerals are released after the weathering. They are held by organic matter to make soil. Decomposition can happen decomposition and mineralization can happen for this organic matter or even for mineral. Minerals can be further mineralized into simpler forms and like your ionic forms, and these are taken up by plants. So you can see plant nutrition is equal to mineral nutrition plus CHO, carbon, hydrogen, oxygen nutrition. Any question, any doubt up to now? Any point of discussion? Pawan?
Sir, I think there are three components of mineral nutrition, like
Okay.
absorption, translocation, and assimilation.
Yeah, that is right.
Sir,
Yeah. Yes, yes. Speak, Tanmay.
sir, that's all, sir. Three components, no? Absorption, translocation, assimilation, sir.
Yeah, this is true. This is true. Mineral nutrition or plant nutrition, in this case, it is absorption, translocation, and assimilation. Fine. Now we go to principles of soil fertility. What are the fundamental principles of soil fertility maintenance? What should be considered as basic principles of soil fertility? First is law of the minimums. Other is law of synchrony and law of nutrient cycle. So these are basic or fundamental things to soil fertility maintenance. So law of minimum, it tells that all the nutrients should be present in balanced amount or at least some minimum quantity or lowest quantity of a nutrient should be present in the soil. So that is good also for maintenance of soil fertility. If one element is missing or is in less concentration, it can affect the uptake of other nutrients. So therefore, first principle is that all the nutrients should be there in the balanced ratios in the soil and right amount. So law of minimum help in knowing that. So that is why it is principle of soil fertility. Another is principle of synchrony. Whatever nutrients are there in the soil, suppose at the time of sowing there are large number of nutrients, large amount of nutrients. But at that time, because plant is in seedling stage, it cannot take up the amount of nutrients that is available in soil. So what will happen, then some of the nutrients will be lost and plant will not use it. But what happens that in the beginning, suppose we don't apply nitrogen in the beginning, that is fine. And we can apply it later when requirement of nitrogen is small. In rice, we can apply it at tilling, we can apply it at panicle initiation stage. So we must synchronize the availability or supply of the nutrient to the requirement. When requirement is more, our soil should have more nutrients, and otherwise when requirement is less, there should be less status of nutrient. And that can be manipulated by external application of fertilizers or manures. So, but this becomes important principle of soil fertility, principle of synchrony. And then through principles of nutrient cycle. It is not as always desirable that whatever nutrients have been removed from the soil and all should be supplied through fertilizers. That is never necessary, because some of the nutrients which have been removed from the soil into the plant parts, some of them should be returned to the soil just to supplement the fertilizers. So therefore, cycling is very, very important. At least ISTA can be cycled, at least if you feed fodder to the animals, and then their dung can make your compost or farmyard manure, that should be returned back to the soil. So nutrient cycling should happen. That is also a principle of soil fertility. If we adopt these three principles, then we can sustain our fertility and productivity. So law of minimum, law of synchrony, and nutrient cycling are the three laws of soil fertility. And you will not find these laws in any book. If any student come across that he has found these principles of soil fertility written in any book, you will not find. But you can find only in one book. I will share that chapter with you, principles of soil fertility. So references are not available, but separately you can find law of minimum, synchrony, nutrient cycle. So you can see the law of minimum, and many of you might be knowing that it was proposed by Justus von Liebig, 1840. What did he say? That plant yield is primarily dependent on the factor that is most in the middle, means the lowest quantity of the factor. Even if all the essential nutrients are adequately supplied, the growth may be limited by another factor, say water. Now the water is adequately supplied, that growth may be limited by the next factor, which is deficient. So the law of minimum can be defined in many ways. First, you can define it in factors affecting plant growth. In that sense, also you can define it. And you can also, if you consider just different nutrients as factors, different nutrients as factor of growth, then also you can define this law. But this is mostly restricted to the nutrients. There are 17 essential nutrients, and carbon, hydrogen, oxygen, you need not to bother. And remaining 14 essential nutrients. Suppose zinc is not there, and you have all the other necessary nutrients, primary nutrients, secondary nutrients, and all other micronutrients. So zinc will decide the growth. If the quantity of zinc is below the minimum, then plants will not attain good growth. If you add the required quantity of zinc into the soil, then another nutrient can become deficient. Then that way you need to increase the supply of that second nutrient also. So therefore, balance is necessary. One should not be in too excess and one should not be too low. So that is the law of minimum. If you want the best result, every nutrient should be present at least in minimum quantities required for the growth. And this can be defined by, understood by many ways. Suppose you have food before you. You have rice, you have chapati, dal, everything is there. But you forgot to add the salt. Will you add this food, eat this food? You will not like to eat this food. You will take 1 or 2 pieces and then you will never eat this food without salt. So if you add the salt, you will eat the food. Similarly, if you add the micronutrients or any nutrient which is deficient, then you can achieve better plant growth. And it is also said that the strength of a chain will be decided by the link, which is the weakest. So weakest link will decide the strength of the chain. Similarly, if you are running on the road, you are in Delhi and having your vehicle, and there is no space to overtake. So the vehicle which is running the slowest will decide the speed of others who are following it. So this is how you can define it, Liebig's barrel, to explain the law of minimum. And it was used by Dobenex. Dobenex used the image of barrel, often called as Liebig's barrel, to explain the Liebig's law. Just as the capacity of a barrel with staves, these structures, wooden structures, are staves of unequal length. They are of unequal length, is limited by the shortest stave. So total quantity of water that can be retained, it can be treated as growth of the plant. So we can see the quantity of growth or quantity of water will be determined by the stave, which is at the shortest distance, which is the lowest length, lowest quantity or lowest length. So that will decide the growth or quantity of water in the barrel. You can see another thing here. This is from the book of Tisdale. You have book of Tisdale, Soil Fertility and Fertilizers. Yeah, Dhyan, do you have that book? Soil
Yes, sir. You have shared during the first semester.
Good. So you can study this law of minimum there also. In that book, some information is given. I just copied from there. So you can see law of minimum, the factor present in least quantity will determine the growth. So instead of taking different nutrients, he has explained it with the help of some other growth factors. For example, in the beginning, suppose variety was not good. Variety was not good. So there was no response to nutrients or any other factors. If variety is poor and you whatever quantity of water you apply, you give ideal temperature, you control the pest, you do everything, but still it will not yield good because variety was a limitation. It was low yielding variety. Suppose now you have changed the variety. Now variety is giving good yield, but again it is infested by local pests. So pest can decrease the yield, decrease the growth, and again you have controlled the pest. Suppose you have good variety, control the pest, then next time temperature can become limiting. You can have low temperature or high temperature, means another growth factor can become limited. Okay, I will overcome this factor also. Then water will become limiting. So it is like this in nature, in agriculture, all the factors are not at their best. So sometimes one factor is limiting, sometimes other. So this one limiting factor will affect the growth. The growth will be affected much by the limiting factor. Similar is the case of your nutrients. Next is principle of synchrony. I already told you that we should ensure that supply of the nutrient is according to the need of the plant. So this is also principle of soil fertility. So the nutrient uptake pattern, if plotted with time, shows a parabolic quadratic curve. Parabolic quadratic curve means initially the growth or requirement is low, and then at rapid growth stage, the requirement is higher, and in the end, the requirement is low. I think if you remember, I discussed the parabolic relationship in principles of crop production at great length, quadratic curve at great length. So it follows quadratic response kind of thing, means uptake of nutrient is related to the kind of growth plants have. So in the beginning, the nutrient uptake is slow, then increases at a faster rate during the rapid growth phase, and finally increases at a decreasing rate, which is followed by a plateau. The nutrient supply should be synchronized with the demand as per growth of the crop. This is the synchrony principle proposed by the ecologist Mike Swift. Mike Swift is the example who proposed a principle of synchrony. And you can remember this name, Swift 1985. This question may come in some of the quizzes. Swift 1985. So here you can see, I give you one example. Example of rice. In rice nutrient management or any other crop, phosphorus and potassic fertilizer, zinc fertilizer, they are generally recommended at the time of sowing. Part of nitrogenous fertilizer in rice is also recommended at transplanting or sowing. The recommendation of ACRIP is that you should apply half nitrogen, at least half nitrogen at the time of planting, and remaining half should be split into two parts. But if you see recommendation from IRA never recommended nitrogen application at the time of transplant. It recommends only 3 splits of nitrogen, one at 10 days after transplanting, another at 25 to 30 days after planting, and third one is at 55 to 60 days after transplant. So these are the recommendations. Why IRA gave this recommendation of 3 splits? Because in the beginning, your seedlings are quite new. Their requirement for nutrient is not that high. So whatever is required is already there. That much minimum nitrogen is there in the soil. So therefore, why to apply basal application in rice? Why? Because plant will not use much of the applied nitrogen for next 15 days at least. So that nitrogen will be liable to be lost. So unnecessarily, we are recommending nitrogen in rice for at the time of transplanting for basal. So that is just to meet the requirement of the crop, split application. And then again, after 55 or 60 days of transplanting, that time you will apply third dose. And after that, you don't apply because then the requirement will fall. Requirement for nitrogen will fall. So therefore, you are just matching the supply and requirement. So this is your principle of synchrony. Then third one is principle of cycling. Nutrients uptake pattern, if plotted with time, shows a, this is over, so. Nutrient cycling. Nutrients are lost by crop removal, erosion, and some other routes. So you know that nutrients are removed from the soil. There are input and output. So output are mainly crop removal, erosion, and some other routes like your volatilization of nitrogen, leaching of sulfate, etc. These nutrients are supplied through manures, crop residues, chemical fertilizers, and biofertilizers. So number of sources are used to supply these nutrients. Certain quantities of these nutrients removed by the crops automatically remain in the soil by default. For example, litter due to leaf fall in certain crops and roots. So whatever nutrients you apply and whatever are there, the total nutrient, out of total nutrients available in the soil, some will be lost by erosion or leaching or other means, and some will be removed by the crop. But some of the nutrients which are removed by the crop, they will still remain in the soil in the form of root or in the form of anchored stubbles or maybe fallen leaves. So they will be recycled. Naturally, they will be recycled automatically. But the nutrients which are removed in the harvest, we should try to bring them back as much as possible. So nutrient cycling should be practiced. Nutrients removed from the soil are to be recycled back by different means to maintain the soil fertility. So you can see the input and output of nutrients. Inputs are your organic manures, supply nutrient, crop residues, fertilizers, BNF, irrigation water also supplies some nutrients, atmospheric deposition. Outputs may be crop harvest, erosion, leaching runoff, gaseous losses, and weeds. These are the inputs and outputs. We need to at least balance them. We need to balance them. If you have less input and more output, someday your fertility will become very, very poor, and then it will not be able to sustain the productivity. So therefore, at least a balance should be removed. Whatever you take out, you must add it into it. Then differences in fertility and productivity. So productivity is the crop yielding. Somebody already discussed it. Crop yielding ability of a soil from a unit area of land is per unit area how much is produced. In other words, potential of a given soil to produce crops or plants is defined as productive. One more definition of soil fertility restricts soil fertility to the nutrient status and soil productivity, then refers to all soil factors that determines the capacity to produce crops. So here, one more definition. This is suggested by Havlin, the Tisdale book. I think you already have this. No, sorry. This is Havlin is Tisdale book. One more definition of soil fertility restricts soil fertility to the nutrient status and soil productivity, then refers to all soil factors that determine the capacity to produce crop. Means Havlin in general do not recognize differences in soil fertility and productivity. There are many more scientists who do not make a difference in soil fertility and productivity. It is mostly in India that people are very much worried about these two things. Whenever you are in interview, the students are in interview, they repeatedly ask this unwanted question: soil fertility, productivity, soil fertility, productivity. Normally, to be very frank and very clear, there is hardly any difference in soil fertility and productivity. We have made some differences, artificial differences in soil fertility and productivity. If you try to get more knowledge, deep knowledge in this subject, then you will find very little or rather no difference in soil fertility and productivity. I don't want to prove it here, but you can remember. But to satisfy the people who ask you question, you need to say, yes, sir, there is difference in soil fertility and productivity, and they are two different things. So therefore, this thing is written here by Havlin. One more definition of soil fertility: restrict soil fertility to the nutrient status and soil productivity, then refers to all soil factors that determine the capacity to produce crops. So relationship between soil fertility and productivity. So as a student, you must say that soil fertility and productivity both are different and there are differences. Already you know the differences in them. So soil fertility is indispensable to a productive soil. If you want highly productive soil, then you should have highly fertile soil. A fertile soil may not always be productive. That is another point. Okay, your soil is highly fertile, but many times it may not be highly productive. A fertile soil may not be necessarily productive one. How it can become, fertile soil can become unproductive, less productive due to poor drainage, weeds, insect pests, diseases, drought, and waterlogging, etc. can reduce the soil productivity. Means other factors other than soil fertility will reduce the productivity, can limit the productivity. Soils having higher productivity are always fertile. This is true. This is true. Highly fertile and highly productive soils are not very common in agro ecosystem. So you need to remember all these 4 points. Tomorrow, if you are sitting in any interview, any exam, if you are not able to answer, you cannot question the teacher that we were not taught. So please do remember these 4 points. A lot of people still discuss this irrelevant issue. So you need to prepare yourself to answer this very irrelevant issue. Anyway, this is in my view irrelevant, but maybe very relevant to people who ask the question, because it is the simplest question anybody can ask. So you see, first thing is that soil fertility is indispensable to a productive soil. Indispensable means it is a must. It is a must. Soil fertility is must to have a productive soil. So therefore, a fertile soil may not always, another point is, a fertile soil may not be always productive. Soil is having good status of nutrients, but still it is not producing good crops. Maybe because of limitation of other factors, like poor drainage, weeds, insect pests, disease, etc. Third point is, soils having high productivity are always highly fertile, are fertile. Because you cannot have higher productivity, first condition is that soil should be fertile. Then comes the other factors. Highly fertile and highly productive soils are not very common in agro-ecosystem. They are not common that you can have very high fertility soil, which is highly productive. So it is there, but very limited area we have such kind of soil which are highly fertile and highly productive. Now, characteristics of highly productive and fertile soil. Just now we have seen that a soil which is highly productive and highly fertile may not be found in agro-ecosystem. Means our artificial system, it is rare to find. But if you found, then what should be the characteristics of highly productive and highly fertile soil? Number one, it is capable of mobilizing nutrients from the soil reserves. The soil reserves can be of two kinds, inorganic and organic. So it should have capacity to get the nutrients released from the reserves. It should not get more fixation of the nutrients. It should supply the nutrients as per demand. Immobilization and chemical fixation, it renders the nutrients unavailable. It should be minimum. There should not be too much of immobilization so that nutrients become unavailable. Or there should not be chemical fixation. Then only you can have a higher status of available nutrients. Organic and fertilizer nutrients are easily transformed quickly into available nutrients. If you apply fertilizers or manure, they should be converted into easily available forms. Minimum losses of nutrients. A soil which is productive and fertile, they should have minimum losses of nutrients. If you have high losses of nutrients, it will not remain highly fertile. Capable of storing the water-soluble nutrients. Soil should be such which allows minimum losses of the nutrients from it. So you can have some more characteristics of highly productive and fertile soil. It supplies the crops a balanced and continuous nutrition as per requirement of the crops. Fit to store and supply adequate water to the crops. This is also important. Fit to store It should have capacity to store water and supply adequate water to the crops. Maintains the acceptable soil aeration or oxygen requirement of roots. So aeration is needed for making nutrients available as well as for microbial activity and other activities. Also for plant roots, you need oxygen. Enhances the nutrient use efficiency by crops, able to supply the plant nutrients throughout the growing season of the crop. Does not contain excessive toxic materials and heavy metals, supports the activities of useful flora and fauna. So these are some of the characteristics. Now the last slide for today is differences between soil fertility and productivity. So soil fertility, these are very man-made differences. However, they are not genuinely the differences. Anyway, because in your exam, it can come. Any exam in your life in soil fertility, such questions can come. However, they are irrelevant. Soil fertility and soil productivity difference is status of essential plant nutrients available for plants in adequate and balanced amount. So this is the definition of soil fertility. You can write any definition of soil fertility here. On the right side, it is soil productivity. This is crop yielding ability of soil or capacity of soil to produce crops. Combination of soil properties and aspect of soil plant relationship. Soil fertility. Combination of mostly soil properties govern the soil fertility. However, here there are a number of factors. Consider the monetary value of produce, not a property of the soil. It is not a property of the soil. Quite vital to productive soils. Fertile soil may not be productive always. A productive soil needs to be adequately fertile or need to be fertile always. These two lines you must remember. Tomorrow, if any confusion is there and you are not able to answer this question, then I may not be blamed for it, that you were not taught. So they are very simple points. Remember, I have seen very few students can answer this simplest question. Anyway, it is improved by decomposition of organic matter, releasing the nutrients, the soil fertility. Organic matter helps in enhancing the productivity of soils. It is influenced by the chemical, physical, biological properties of the soil. Productivity is influenced by soil fertility plus all other growth factors. So these are some artificial differences. Tomorrow I will start with current status of soil fertility in India. Now, do you have any extra time? Or you have some other class? Hello?
Sir, we have statistics class, sir.
Okay, so I stop here and we meet tomorrow at 9:15. Tomorrow I will straightway start the topic and you can come up with questions also, but still 1 or 2 minutes are there. If any question is there, it is time to discuss. I encourage you to discuss the things